knowing the hydronium ion concentration is necessary in many different instances. But since the values for the hydronium ion concentrations were all very small and they were negative powers of 10, a more convenient scale was created, and that's the pH scale. So the relationship between the hydronium ion concentration and pH is given right here. So pH is equal to the negative log of the hydronium ion concentration. And so one thing that this might pose a challenge is you might not have used your base 10 log log in your calculator in a while. So you'll need to look for that on your calculator to make sure you can find it and use it. So the range of the pH scale then, when we get there, it's going to go from 0 to 14. And a neutral solution is going to have a pH of 7. And if you recall from the previous video, a neutral solution has an acid concentration that's equal to 1 times 10 to the negative 7. Okay, so it corresponds to a pH of 7. Now, when you have an acidic solution, the concentration of the acid is greater than 1 times 10 to the negative 7. And because of how the logarithm scale is set up, and we're going to do calculations on the next page, a concentration that's greater than 1 times 10 to the negative 7, for example, 1 times 10 to the negative 3, actually has a pH value that's less than 7. So if you're acidic, you are less than 7 for a pH. Now, a basic solution, if we're looking at the acid concentration now, so in a basic solution, the acid concentration goes below 1 times 10 to the negative 7. So the acid concentration is less than 1 times 10 to the negative 7. And in terms of calculating the pH, then the pH gets larger than 7. So the pH, this is more than 7. So if I was just kind of creating, if I have up here my little range, and very roughly so, and let's have 7, this is my neutral, right? Trying to cram too many things in here. There's my neutral. And so then if I had acidic, so that's all down here, 0 to 7. This is acidic. And then our basic would be up to 14. So this is basic. Okay, so on the scale, less than 7 is acidic and greater than 7 is basic. Now, a couple of things I want to point out with regard to this is, one, the lower the pH value, so lower pH indicates higher acid. Okay, so lower number gives more acid concentration. And then here, the second thing is a small difference in pH actually equals a big difference in the hydronium ion concentration. And so what I want to tell you is that's an awful color. Let me change my colors. I was trying to make it a little more interesting having other colors, but that was too awful. Okay, so 1 pH unit. So 5 to 6, 6 to 7. So 1 pH unit equals a 10 times change in concentration of the acid. 10 times. 10 times. So for example, a pH of 6, which is more acidic than a pH of 7. A pH of 6 has 10 times more acid than a pH of 7. And then it's not 10, 20, 30. So let's say it goes down to a pH of 5. So if I'm comparing a pH of 5 to a pH of 7, that's 2 units in pH. That's 100 times more acid concentration in a pH of 5. So each time you drop a unit in pH, you're 10 times more acid. each time you go up a unit in pH, it would be 10 times less acid. For each unit, you get 10 times more or less. So it's a big difference. Sometimes, and I'm emphasizing it because a 1 seems so small, but when you're talking about the logarithmic scale of pH, it's a 10-time difference. So let's take a look and see how we would use these two equations up here. So here's the two equations that we might use. And let's see how we would use these to do a calculation. And you'll need to get your calculator out. So the first one is when you want to calculate pH. Well, the first two. So if you want to calculate pH, then the equation that's going to help you is this one. Because there it tells you what we do for calculating pH. So in this case, we would say the pH equals the negative log of 1 times 10 to the negative 3. Now you can pause this and put it in your calculator. And you should get the number 3. Now this is pretty cool. And if you are looking, let me find a different, I'm trying to find a highlighter that I can use. There we go. Sorry. Okay, so if you look, what you'll notice is this number is 3 right there. So if that number is 3, and this number, another thing you'll notice here, this number is a 1. So anytime your coefficient is a 1, the pH is going to just be equal to the positive value of your exponent. Now it's only true when the coefficient is a 1. So in this example, I wouldn't even have to put it in the calculator. I could just know that the negative log of 1 times 10 to the negative 3 is 3. Now this next example, I will have to use my calculator. I don't have any logarithm tables. So I want to calculate the pH. So I know the pH is equal to the negative log of the acid concentration, which is 8.7 times 10 to the negative 12. So you can pause the video and plug it into your calculator. And I get 11.06. Now, you may say, well, why didn't you just say 11, or why didn't you just say 11.1? Now, if you wrote down 11.1 on the exam, I'd give you credit. But the convention for how we write pHs, we decide how many decimal places we're going to go based on our coefficients. So the coefficient, this had 8.7. So there was 2 digits in the coefficient. So the convention is that then I would want to go to 2 decimal places. So instead of saying 11.1, I'd round to I would go to 11.06 because my coefficient had 2. So then it's not talking about total numbers. It just says then I would go to 2 past the decimal here. So that's the convention of that. Now, the third example that I have is a little different. This one wants you to calculate hydroxide ion concentration. And so that's where this equation comes in. Now, the truth is, and those of you who remember working with logs frequently, you'll recognize that these two equations are actually the same equation, just rearranged differently. So the first one, I had pH as the thing I was looking for, and it was by itself. If you rearrange that equation and make the hydronium ion by itself, then this is what you get. I will give you both of these equations. Okay, so if I want to calculate that, so I know that the hydronium ion concentration is equal to 10 to the negative pH, so the negative 4.2. So in my calculator, I'm going to plug in 10 to the negative 4.2. And I get, now my calculator gives me 0.00040 zeros. 1, 2, 3, 4, 6, 3, and that would be one way. Or usually these are written in exponential notation, so let's move the decimal. 1, 2, 3, 4, 5. So I would get 6.3 times 10 to the negative 5. And actually, which I know that you're going to hate this, but if I was trying to think of, since this only had, since what I was given only had 1 past the decimal here, it would mean that my coefficient only had 1. So I could also accept 6 times 10 to the negative 5. If you wrote on the exam, and I think as well as in your homework, I don't think it's going to get you for this, but if you wrote on the exam 6.3 times 10 to the negative 5, I would accept that answer. Or as well as if you wrote 0.00006 or 63, I would also accept that answer. Now it's a little harder to show you your calculators on this video, so if you find that you're struggling entering these into your calculator, your book has some instructions. You can Google it online, or a good thing to do would be to come see me in class, and I will go over with it step by step with your specific calculator.